Hi everybody, today we're starting a new unit on equations of linear relations. So we're still continuing with linear relationships, but we're now going to start looking to analyze the equations of our various lines. So the first lesson we're going to do is we're going to look at the equation of a line in the slope y-intercept form. And we're going to see this is y equals mx plus b, which some of you might have heard of before. So that's the topic today. We're going to analyze that equation and see how it relates to our graph. Okay, so let's just jump right into it. Let's do this investigation here. You can do it on your graphing calculator. I'm just going to do quick rough sketches because I kind of already have an idea of what these graphs are going to look like. And again, remember, to do a sketch of any graph, you can put this into your graphing calculator, or you can do a table of values. So just really quickly, just to remind you of that, I can do a table of values, and I can put my, x's here and my y's here. So again, when x is -1, let me move this over a little bit. Y is going to be -3 but -2. When x is 0, also the y-intercept there, y is 1. When x is 1, y is 4. When x is 2, y is 7. So you quickly, now I can just plot those coordinates, something like this. And we quickly start to see a line form that looks something like this. Now your graphing calculator can give this to you much quicker, but anyway, that's this line here. This other line here is going to be going to look something like this. And again, if you don't believe me, you can do a table of values or use your graphing calculator. Okay, this one here is going to be it's going to have an interesting shape. Notice the x and then to the power of 3 here. It's going to look something like this. And again, you can do a table of values just to see why it looks like that. This one here is going to look something like this. And notice how I put arrows at the end of the line to show that it keeps going on forever. This one here is going to look something like I believe it's going to be something like this. So we can get all sorts of interesting shapes, by manipulating where the variable is and what exponent we have in the variable. This one here is going to be something like this. Okay, this one is going to be it's going to be very steep. It's going to be like this. And finally, this one is really interesting. This sort of exponential one is going to be like that. Okay, so what we notice here. And the question says down here, what's which ones are linear and which ones are nonlinear? Well, all the linear ones are when we have a straight line. So what do you notice if we're comparing the lists here, and if we want to come up with some sort of a rule that determines if we have a linear versus a nonlinear equation? Well, the rule would be, if you look at our variable, and that is, I'm going to just highlight the variable here. If you look at the variables, here I have x, x, and x, and notice that there are no exponents on the x's. The x is in the numerator, so that can be your rule. If you have, if the x variable has no exponents and it's in the numerator, then you can have a linear relationship. Otherwise, if you notice here, I have x cubed, x squared, 1 over x. Here it's the denominator. Here the x itself is the exponent. Any of these cases are going to give you curved or nonlinear shapes. Okay, so that can be a general rule for determining whether your graph is linear or nonlinear. Okay, all right. Let's go ahead and do some further investigating here and to see what we mean here by y equals mx plus b. All right, so we have this graph, y equals 2 over 3x minus 1. And if I do a table of values, or if I use a graphing calculator, I'm going to get this line over here that's nicely sketched out for us. Okay, now let's look let's see if we can find the y-intercept of this graph. Well, the y-intercept is right here, and that corresponds to y-intercept, and that equals -1. Okay, and the slope, well, remember the slope from last unit, we can calculate the slope using just using rise over run. So I make a triangle. So the slope, and I'm gonna make the slope as m. So rise over run, and the rise is gonna be so just 2, 1, 2, and the run is gonna be 1, 2, 3. Okay, so I have my slope, and I have my y-intercept. Well, what do we start to notice here? It says here, compare the values found in A with the coefficients in front of the x. So let's look at, I mean, this starts to match up here. Well, there, the 2 over 3 is here, and the -1 is right here. So this is very nice, okay? Because when we have our equation of the line, y equals mx plus b, and in this case, this is your m, and this is your b here, the m is the slope, and the b is the y-intercept. Well, that's very convenient, because we don't even need a graphing calculator or a table of values to graph our equation if we know the slope and the y-intercept. Really, those are the only two pieces of information you need to graph a line. Okay, let's do some more practice here. Okay, here's another example. Y equals 2x plus 1. Well, the slope in this case would be 2, or I can write 2 over 1, and the y-intercept would be 1. And let's go ahead and check that. Well, there's the y-intercept. It's at 1, and the slope would be up to 1 over, up to 1 over, 2 over 1. Okay, rise over run. So that works there. In this case here, the slope would be -5 over 2, and the y-intercept would be -3. And there's my equation, y equals -5 over 2x minus 3. And if you don't believe me, go ahead and sketch this yourself using a table of values, and you're going to get this this line here that goes through -3 and has a slope of, let's see, let me pick these 2 points here. I'll do them in red. Right there. So we're going to go 1, 2, 3, 4, 5 down, and then 1, 2, 2 over, and there it is, -5 over 2. Okay, so it says make a conjecture about the slope and the y-intercept of the graph of the linear equation. Well, if it's in this form, again, I'll say it, y equals mx plus b. The m is your slope, and the b is your y-intercept. Okay, and again, keep in mind that the m has to be in front of whatever variable is in front of the x, whatever coefficient is in front of the x, that is the slope. All right, so let's go ahead and make a little do another example here. So I think I'm going to skip this and just go right into the questions here. Okay, so determine, and here's your general rule. Make sure you highlight this, what I just said above. The equation y equals mx plus b is known as the slope y-intercept form of the equation of the line because it shows you the y-intercept and it shows you the slope. So hence the slope y-intercept form. Cool. All right, let's do example A. Determine the slope and the y-intercept of the graph in each linear equation listed below. So the slope is 3 over 1. I like to put it like that, so I know it's rise 3 over run 1. And the b value, which is your y-intercept, is 2. Oh, in this case, be careful here because, again, this here would be your slope. Whatever's in front of the x, -2 over 3, and the b, your y-intercept, would be 7. And quickly you can make sketches here, because if the y-intercept is 2, 1, 2, and the slope is 3 over 1, so up 3 over 1, up 3 over 1, up 3 over 1, I can quickly make sketches of all my graphs. This one here would be 7, so way at 1, 2, 3, 4, 5, 6, 7 starts here, and it's going to be down 2 over 3, down 2 over 3, down 2 over 3. It's going to look something like this. Okay, this last one you have to be really careful, because slope, the slope y-intercept form only works when it's y equals and then, you know, something something something. And in this case I have, where am I here? In this case I have the 6 here, which is a problem, so I have to send that 6 over to the other side before I can, you know, before I can start getting my y-intercept and my slope. So let's go ahead and deal with that. So 6y equals 8x plus 1, and I want it to be y equals, so I need to get rid of the 6, so I'm going to divide both sides by 6. Okay, and then only now, this is important, only now when it's in this form, y equals something, can I look at the y-intercept and the y-intercept and the slope. So again, let me write these down. So the slope would be 8 over 6, and you can simplify that to 4 over 3, and the y-intercept would be 1 over 6. All right. Okay, so then knowing that, we can do some graphing here. Again, now the beauty of this is we don't actually need to do a table of values or use our graphing calculator to give us a quick sketch. All we need is the slope and the y-intercept, and the slope in this case is going to be 2. The y-intercept is going to be negative 5. Therefore, you know, I can graph this because I know that my y-intercept is negative 5. Well, there's the y-intercept, 1, 2, 3, 4, 5 right there. And my slope is 2, or 2 over 1. So I'm going to go up 2, 1 over, up 2, 1 over. And basically, once you get 2 points, you can get your ruler out or do a sketch with your hand, and there we go. Okay, and then it says use the y-intercept in the form the slope rise or run. Mark 3 other points. Okay, so I did all that. Verify the graph using a graphing calculator. Sure, let's go ahead and do that. So let me plug this in. So what is it? Y equals 2x minus 5. Get into my y equals 2x minus 5. I'll hit graph. Okay, there you go. So the scale is a little bit different, but more or less we have the same graph. All right, moving on. Okay, let's do another one. State the y-intercept negative 6. And then it says determine the x-intercept algebraically. Okay, we have to go back to 2 units ago to figure out how to do that. The x-intercept, we know that y equals 0 at the x-intercept, so I'm going to go ahead and make y equals 0 and solve for x. In this case, it's going to give us, let me see, I'll move the 6 over. 18 divided by 2, 9. X equals 9. Okay, so that is the x-intercept. Let me go ahead and mark that. 1, 2, 3, 4, all the way to 9 here. The y-intercept is at negative 6, because we can just read that off the graph. Negative 6. And again, so now that we have both the x and the y-intercept, again, all I need is a ruler. And you can't see this on your screen, but I'm actually getting a ruler out here. Okay, and I'm just gonna make my join those 2 points and make my line there. Okay, there we go. All right, so that's it for this lesson. Let me just recap again what the main purpose of this is. This equation, which we've seen before in our previous units, now has more meaning. And more specifically, the meaning is this: when it is in terms of y, so y equals something something something, that something gives you the slope and the y-intercept. This is the slope and that's the y-intercept. And once you have those 2 pieces of information, you can graph any line, because all you need to do is start at the y-intercept and then again up 2, 3 over, up 2, 1, 2, 3 over, up 2, 3 over, up 2, 3 over, or down 2, left 3, down 2, left 3. Okay, there it is. All right, so hope you understand that, and we'll see you in class.